So as Craig was saying, my name is Welton Davis. I'm from Johnson & Johnson Vision Care. We're based out of Jacksonville, and I'm here. I'm going to tell a story of how Tell-It, device-wise, saved our lives, basically. So next. A little bit about us. We have two manufacturing plants. One in Jacksonville, which is our headquarters. We make about 3 million units, or that is lenses, daily there at that plant. And we have a sister plant in Ireland, which is a little bit larger, and they do about 5 million units daily. There's about 2,500 personnel at our Jacksonville plant, and about 3,500 in our Limerick plant, rounds about. Some of the products that we make, the AccuView brand is our flagship product. We have other variations of that brand, AccuView 2, AccuView Moist, and AccuView Oasis, all products that are out in the market. Can't quote what our market share is, but all I can say is it's pretty large. So we had a problem a couple of years ago. We have, this is full disclosure, I am an engineer that went over into IT, so I'm not going to offend no IT people or engineering folks. So we had this issue where the engineers went out and built this very expensive machine and didn't tell the IT folks anything. They went through all of the normal processes, got this machine to the factory, put it on the floor, get ready to do the IQ, hooked it up to the IT systems, and nothing happened. So at that point, they went looking for some help. So they came to our group, and they said, well, hey, guys, we can't send any transactions up to the DHR systems or any of the MES systems. What's going on? You must have done something wrong. Well, it wasn't us. You guys never talked to us. So what they had done is they changed the operating systems of their human-machine interfaces and didn't let IT know. And it's an honest mistake. They've done it before. There was no problem. But this time, they switched from Windows 2003 to Windows 2008, which was a 32-bit operating system previously, to a 64-bit operating system, and the COM components, component object model components, don't quite work the same. So all of the interfaces that we had previously built were built for a 32-bit operating system. So they had to roll everything back, long story short. So it wasn't, all of the operating systems had to go back to the older 32-bit operating systems, created several weeks delays as far as their timeline for when they were going to bring the machinery up and get it through the full validation process. Tied up a bunch of IT folks' time that was not previously allocated, so it's a lot of problems. So enter myself and a couple of my colleagues. We looked at where the engineering folks wanted to go and where we were. They had standardized that particular system on Wonderware. Wonderware is a human-machine interface that was, I think, now built by or sold by Schneider. The system in which the IT systems communicated to the HMI was through this component called InTouchCom DLL, which is the COM component that failed. What did I just do here? There. So this component, InTouchCom DLL, was a 32-bit component that that failed once they moved to the 64-bit operating system. That component was built in 1999, so that's how long they had been reusing this interface, so about 16, 17 years. And they had gone through all the iterations of operating systems from 1999 till 2000, and it had to be like 2013, I believe, 13, 14, with no problem. So that's the legacy architecture that the systems worked are in. They had our IT communications would talk to the InTouch application through this interface, and the InTouch application would talk down to the programmable logic controllers and other systems such as vision systems. Could be pretty much anything InTouch had a driver for. We have an additional architecture on these same manufacturing platforms that leverages another technology from Wonderware InTouch, which is their orchestra technology. And that's what this middle architecture is on the here on the slide here. It pretty much works the same as the InTouch COM, but it's a bit more complex. Engineering doesn't like it. Just long story short, it has a lot of moving parts. So we have, as I mentioned before, we're headquartered out of Jacksonville. Our R&D department is is out there as well, and we kind of got wind of they had found this technology or a tool that they were using to do some things over there. At the time, it was called ILS. That's how everyone was referring to it. So we were in the midst of trying to figure out how to solve this problem, and one of the R&D engineers came up and said, "Hey, we had some guys up from Boca Raton. The guy was there like 20 minutes, and they were up and running." So that sounded real good to us because, you know, we had some time that was not allocated for. So we got in touch with the folks from Telit and brought them up to Jacksonville, or invited them up to Jacksonville, and they described to us their product. We did a few prototype or smoke tests, and we implemented it in this architecture here. So it's significantly simplified what we had been doing previously. But not only that, it enabled us to reverse engineer this InTouch COM DLL and this orchestra component with a little assistance from Telit. And we were able to retrofit all of our engineering and SIM and IT applications, with the only change being the communication protocol. So basically, we did that in probably about 7 or 8 weeks of design, probably about the same in development, and so around about 6 months, we went from basically being dead in the water to back up and running and fully validated. So we've taken this one step further. This problem occurred only on one application, so inside of the product device-wise, we noticed that we could potentially obsolete total applications that we had built, because our factory is built is architected on manufacturing platforms, of which we have 4 right now. Platforms in the sense of the actual machines that make certain products. So in one of our platforms, we have custom off-the-shelf MES systems and communication protocols. And I say custom off-the-shelf, but it's highly customized commercial off-the-shelf products. So And then on one generation, which is where this problem occurred at, is all of our applications are custom built. Well, now which means that we had to come up with the protocols, go through the whole design, whole event model, the whole 9 yards. Well, what we found is that if we use the device-wise connector, we could obsolete those IT applications up there, build them with the project trigger methods in device-wise project itself. So essentially, we're sucking all of our IT applications into one commercial product, which simplifies our change control, simplifies our interface with the engineers, because the engineering group has a common interface. They feel very comfortable working with this product as opposed to our orchestra. And they didn't even know what was in InTouch Com DLL, and we didn't either. We just knew how to use it because it was built by a company called Lighthammer, which I don't even think they're even in business anymore, in 1999. So, and it was, it was a binary object. So this, once we implemented the device-wise platform on those, on our manufacturing platform, pretty much the sky was the limit of what else can this product do for us. So this kind of talks about what I kind of alluded to earlier, our timeline. And literally within 4 weeks, we re-engineered this product into our existing solution. We're in a GXP FDA regulated environment, just like the folks from BNL. And so that's got its own set of challenges. Once we went through that, we put it in and literally didn't have a hiccup. There was the hypercare for the product was next to nothing, which kind of goes along with the drop-in support-related issues due to communication, IT, and our automation layers. And right now, in fact, we had to break away to come up here because we're in the midst of retrofitting all of our legacy systems to the Telit device-wise product because of its simplicity and ease of use. The lessons we learned from this this episode, which was actually kind of painful when you think about it from the engineering perspective, bringing it in. So there was a lot of panic, but it really had a very good happy ending. We recognized that we could have very reliable communication transactions between the IT group and the engineering group applications. The big thing from IT is we run 24/7. Everybody's on his own call rotation. We had drop-in support, which made everybody really happy in my group. We also, because of the success that we had at the automation layer, we found a couple of other uses for device-wise for gathering data analytics. There's another group that's using it for that. We have some folks that are using it in some of our facilities, engineering applications to gather information and send information to some IT systems about our raw material handling. And the biggest one, the one that I think most of the engineering group and my group like the most, is that the implementation of the project triggers is like having an application encapsulated in another application, and a lot of the functionality inside that application that you kind of configure, because you're really not doing a whole lot of building or developing. It's more configuration. And in our environment, when you say configuration, that makes people feel a lot more comfortable than when you say, hey, I'm developing something. So that was a huge advantage for us. So, and that's pretty much the story of how we were successful in using the ViceWise platform.